Our agenda here today for this 1-hour webinar is we'll do a very brief review just to get us all on the same page. I know some of the folks here are new and weren't here for the introductory session, so that's fine. We'll do a very, very brief review. But most of today is going to be dedicated to the idea of geolocation, orientation, and shading. So one of the main things that people are using DesignPH for is doing shading analysis. And we're going to look both at how we do that in a interactive way inside the Sketchup engine, so using some of the Sketchup native tools, but then we'll definitely dwell quite a bit on how we do the quantification and calculation using the brand new DesignPH 2 shading methodologies. So if you're not familiar, DesignPH 2 is a new piece of software that came out last year, and it's got a significantly overhauled shading calculation procedure when compared to the older PHPP version 9 or DesignPH version 1.5. So we have a whole new way of doing DesignPH, and we're going to talk about that in a lot of depth here today. Just briefly, a little bit of housekeeping here. If you have any questions at all, feel free to post them in the chat or use the little raise hand icon. If you click on the participants window in this Zoom call, you should be able to raise your hand. If you're not speaking, if you're just watching, please do keep your mute on just to avoid any potential for background noise. And if anything happens, Zoom bombing or whatever, we will shut down the session and we'll try it again in another couple of weeks. So just sort of basic housekeeping stuff there. And again, if you have any questions, feel free to add them to the chat. Hopefully we'll save some time here at the end to do a little bit of live demo and do some question and answer. So with that, let's kick right off. Before we get into shading, I do want to take just a few minutes and talk about the just a basic review of some of the things we went over last time, just to get everybody on the same page. DesignPH. DesignPH is a plugin for the 3D modeling program Sketchup. If you're not familiar with that Sketchup tool, it's just one of many 3D modeling tools available on the market. It's a relatively low cost, relatively easy to use 3D modeling software. It does surface modeling, and it's very popular within the architecture industry in particular. It has some free or very low cost options, and then some sort of more expensive professional versions. Like everything else, there's a sort of hierarchy of versions that you can get. But you'll need that SketchUp 3D tool. You'll also need a copy of DesignPH. So DesignPH 2 is the most recent version of DesignPH. And then you'll also need a copy of the PHPP, either version 8 or version 9. Hopefully everybody's working in version 9 at this point. So you'll need all three of those in order to execute any of the things you're going to see here today. So you'll need that whole set of tools in order to be able to complete the work that we're going to show here in this session. If you don't have DesignPH 2 already, and you're in North America, the easiest place to get it is from the web store. We get ours from 475 High Performance Building Supply, so you can get that right through their web store. If you're in the US or Canada, if you're international, you could get it through the PHI web store. There's a couple different places that you can sort of purchase DesignPH depending on where you are in the world. But if you're in North America, probably the easiest is to get it right from 475 there. Again, that's where we get ours. SketchUp, as I said, is a separate program, so you're also going to need SketchUp. You could just go to sketchup.com if you don't have SketchUp already installed on your computer. There's a free version, not terribly useful if you're a professional architect or engineer, designer. You're probably going to want to spring the couple $100 for the real version of the program, but you'll need that as well in order to run this. SketchUp, as I said, is a relatively easy to use, relatively simple surface modeling, 3D modeling tool, and we're going to show some of the functionality that it has here today. We'll walk through some of its tool set, in particular that dedicated to shading. Now, DesignPH, as I mentioned, is a plugin for SketchUp. So first you buy SketchUp, install SketchUp, then you get DesignPH, and you install DesignPH as what's known as an extension. So that's the term that is used in the SketchUp world for all of the various bits and pieces that you can add to SketchUp. So SketchUp's an interesting beast. It has a very robust third-party development ecosystem. Lots of people make plugins for SketchUp, and you can install them through what's called the Extensions Manager. There's a whole online, what they call it an extension warehouse, where you can get lots of different plugins that do lots of different things. One of those plugins is DesignPH, and it allows you to do passive house modeling inside of SketchUp. So you're going to install that DesignPH tool once you have SketchUp successfully installed on your computer. Now, once you have DesignPH installed on your computer, you're going to have a couple of new tools that'll become available to you inside of SketchUp once you start your SketchUp model. One thing to note here is that every time that you start a new SketchUp model, so you come in the morning, you boot up your computer, you turn on SketchUp, you're going to need to start or boot up the DesignPH extension. So by default, when you start a new SketchUp file, DesignPH isn't started. It's sort of living in the background, but it's not taking up a bunch of system resources. When it's time to start modeling, you have to press that passive house P, that little passive house P there in the toolbar on the left, kicks off the initialization sequence, and it starts up the DesignPH tools. So those won't be available until you start up the DesignPH. So you got to do that every time you start a new SketchUp session. So hopefully that's all obvious to everybody. In terms of basic workflow for DesignPH, just to revisit very briefly what we went over in the last session, it's essentially a 5 or 6 part workflow. We're going to model our building. We're going to do all the 3D modeling. We're actually going to build out our model in 3D in the SketchUp engine. We're going to tag or associate parameters with individual pieces of geometry, so individual surfaces, individual windows. They're going to get tagged or associated with bits of information. We're going to create a building, what's known as a building information model. So we're going to start to build out a bunch of data and associate that with geometry in our model. We're then going to analyze the model. We're going to do that using some DesignPH tools. So there's a specific analysis functionality, which is built into DesignPH. We're going to do an analysis phase, and then we're going to do an export phase. So once we're done modeling, once we've tagged everything, we've managed all our data, we've done the analysis, we're going to export all of that data out of DesignPH and move it into a PHPP. So the last couple steps in the sequence here don't take place in SketchUp any longer. We're going to take that data and move it from SketchUp into the PHPP numerical energy model. The SketchUp or the DesignPH 2 is really a graphical front end for the PHPP. It's not a replacement for the PHPP though. It allows you to interact with and get data into that numerical Excel model, but it does not replace that numerical Excel model. So just to flag that. Again, we'll have some other sessions around all of this exporting and PHPP side stuff, but just to sort of lay out the initial sequence of steps here, this would be the typical workflow that we would employ when working on a project. So that's our 6-step sequence when using DesignPH. Now, in terms of today's session, so that's all the review. We kind of went over a lot of that in the last session. We'll go over it in future sessions as well. But today, again, we want to spend our time talking about geolocation, SketchUp orientation and axes, shading, both in SketchUp and in DesignPH. So let's start that discussion by talking about the SketchUp side of the equation. Let's hold off on DesignPH for a minute. Let's just talk about SketchUp. So the next session, everything we're going to talk about is just basic SketchUp. Talk about geolocation and orientation. Now, when you start up a brand new SketchUp file, when you start a new scene, you're presented with something that looks roughly like this. You might have slightly different colors. You might have a different person, depending on what version you have there. You know, those things change over time. But in general, it's going to look like something like this. You're going to have a couple of different colored axes present in the scene. By default, that green axis, it's called the y-axis, is pointing to the north, and that red axis is pointing to the east. That's how SketchUp is designed out of the box when you first start it up. That's how it's going to start up every time. So the green axis points to the north, the red axis points to the east. Now that's fine, but and that's a sort of, it's just a general generic location. It doesn't really exist anywhere. If we're working on an actual project, an actual building in a specific location, we want to use what's known as the geo-location tool in SketchUp. So either before or maybe soon after we've done our modeling, we're going to want to geolocate our model. And we do that by going to Window, Model Info. So you can see there with the drop-down menu, we go to Model Info. And inside of Model Info, if we go to Geolocation, we have the opportunity here to add a specific location. So we can either set that manually by typing in on longitude and latitude, or we can press that button there that says Add Location. And that'll bring up a Google Maps style interface where we can either type in an address, or we can just zoom or pan around just as you would do in Google Maps or Google Earth or any of those typical tools. So you're going to navigate to your specific location, wherever that might happen to be. You're going to find your location. And once you've zoomed in to a far enough level of detail, some new tools will become available. All of a sudden, you're going to see a little tool, a little button on the right-hand side that says import, and you're going to see these little handles appear that define a boundary. What we're going to do here is we're actually going to grab this chunk of this map and import it into our SketchUp scene. Our SketchUp scene is automatically going to geolocate itself to the center of this import. And so we will have both set our longitude and latitude, and we will have imported this base map and topography into our SketchUp scene all in one step. So really, really nice functionality, really easy to use, allows us to very, very easily and simply locate our building in space. And luckily for us nowadays, there's a tremendous amount of detail in these base map files. So we can get a lot of information very, very quickly just by using this geolocation interface. Once we press import on the right-hand side, what'll happen is that chunk of the base map that we defined gets dropped into our SketchUp 3D model scene. So we now have that to work off of. Everything's been, I should note, it's also been scaled appropriately. So both the scale and the location come in automatically, which is really nice, right? So that makes our life much, much easier when it comes to building out things like context as well as our building. Now, one thing that you'll notice here, though, is that our axes, those are our drawing axes. Those axes are almost never going to align to whatever the axis is of your base map there. Let's say you have a project like this and you're trying to build out one of these row house buildings here. Well, obviously the green and red axes don't align to those buildings. And so we're not going to be able to draw accurately. Those drawing axes allow us to do what's called inferencing, which allows us to constrain our edges and our surfaces to the X and Y axes very easily. Keeps our drawing tidy, avoids any small gaps or errors in the drawing process. So it's important to align those axes with your actual geometry. We're going to do that by using the axis tool. So SketchUp has a tool that allows us to reset this construction plane axis or this work plane axis. And that's going to allow us to actually draw or model our geometry much more accurately, much more easily. So once you've brought in your base map file, the next step that we like to do is use the axis tool. You can either deploy it from the floating toolbar up in the upper left there, or you can go to Tools and click Axis. And in order to use it, it's quite straightforward. You specify a new base point, and then you just use your mouse to drag out a new X and Y axis. So for instance, if we were to go to a top view of our imported base map, and we were to select a base map or a base point in maybe the upper left of our block of townhouses here, and then we use our mouse to simply drag in one or another direction to set the X and Y axes. Now it's important to remember here, you have not reset the solar orientation here. In this case, when you use the axis tool, the only thing you're doing is resetting the drawing axis to allow you to model correctly. North is still up. So if you go to top view, north is still up in this case. So the geolocation stays, the solar orientation stays. The only thing you're doing when you adjust the axis is you're changing your drawing axis, or we call it the construction plane axis. If you now begin to model, what you'll find is that your modeling will be constrained to those new X and Y axes. And so you're not going to have small gaps between surfaces. Your lines will be nice and straight. They'll all be at 90 degrees to one another. It's a easy, cleaner way to draw all your geometry. Of course, you might want to go back to the original, the world XYZ, the world construction plane. That's totally fine. If you sort of zoom out a little bit, you right-click on one of the axes, like the blue Z axis, and just click that button that says Reset. That Reset button will reset everything to the world XYZ axis. So you can always go back to that original axis, and you can always use the axis tool again to change your construction plane to your rotated axis. So you can move back and forth between your axes all day long. Again, you're not going to be changing solar north in this case. The only thing you're changing is your construction or your drawing axis. Solar north is always going to be up. So if you're in top view. So All important, all critical if you're going to be accurately modeling in SketchUp. Important to understand the distinction between those different tools, to understand those tools. Those are all going to be critical for successfully working inside SketchUp. Now, once we've done that, once we've built out our, or once we've established our geolocation and we have built out our model, one of the things that we're almost always going to do is we're going to evaluate the site shading using SketchUp's native tools. So again, before we talk DesignPH, let's talk a sort of qualitative assessment here using SketchUp's built-in shading tools. So let's say, for instance, that we, in that little block of townhouses there, let's say we're working on one of those, and so we build out the building, we do all of our modeling, we build the windows, we build all the surfaces, we tag everything, etc. So here's our little building in the center here. In terms of overall site shading, so we're going to see in a minute, we're going to be able to assess the shading implications of the neighboring site. You can see here the way that a scene like this might get set up. We have our rotated construction plane axis. So solar north, again, is up in this top view. So it's sort of straight up, but the construction axis has been rotated to allow us to model appropriately. And then we've modeled the site context for about 100 meters in every direction. So this maybe starting from the center of the building, go 300 feet or so in every direction, model in the relevant site shading. Big trees, big neighboring buildings. If we'll see in a second, if you have some other elements that are really large and even further away, you might load those in. But for most cases, about 100 meters in every direction, about 300 feet or so, is going to be suitable for the type of shading analysis that we're going to be doing here. So we're going to build out that entire shading context for our model. Now, what happens if you do have something where you have really large site shading, which is really far away? Let's take, for instance, a situation like this, where maybe we have some really large hills, maybe in a sort of valley. We're building in a valley between two large hills. How would we build those out into our SketchUp model? Well, one of the other things that comes in to your SketchUp model alongside that base map is actually the base topography. So if you've ever used Google Earth or anything like that, where you can actually sort of spin around in the topography of an actual location, all that data is available to us and we can import it. In fact, it is imported automatically when we use the geolocation tool in SketchUp. So for instance, all of this site topography data here is actual data from GIS base maps, which is brought into our SketchUp scene automatically. So for instance, this little building here is a tiny building. You can see it in the sort of middle there next to the axis, the tiny little building there in between a couple of really large hills. Right? And again, this is all brought in automatically. We don't model this. This is all imported from our geolocation tool in SketchUp. This is fine. You could go ahead and perform your shading analysis using this geometry. That's totally fine. What we have found, though, is that this is going to significantly slow down the analysis phase when it comes to the DesignPH workflow. So we haven't gotten to DesignPH yet. We're going to get to that in the next little bit. For now, this is fine. You can use this to do a qualitative site shading analysis. But if you have really detailed high polygon geometry like this topography, that's going to really slow down the analysis, and it could take 5 or 10 minutes to do your shading calculations when it comes time to do DesignPH. So what I recommend doing, what I do with our projects, is we cut a couple representative sections. For instance, you can see those kind of grayish planes there. What we'll do is cut a couple sections that describe the topography or the relevant topography, and then we'll either hide or delete the actual topography out of the scene. We then do our shading analysis in DesignPH using this simplified planar context. This is going to be perfectly suitable for establishing shading factors for a situation like this. It's also going to be a lot faster. The number of polygons matters quite a bit when it comes to speed of shading calculation. So the number of polygons, you want to keep that as low as possible. Here, the number of polygons is 3, right? As opposed to the topography, where the number of polygons could be thousands and thousands. And yet they describe basically the same shading condition. So, you can do it either way. This is my recommendation. This is how we do it in a lot of our projects when we have context like this, where we need to drop in some large elements. In any event, however you've built your site context, however you've put that together, SketchUp has a couple of built-in tools to allow us to do shading assessment. So if you don't already on your SketchUp scene, you can go to Window and click the Shadows button, and that will load up or open up the Shadows dialog window. The Shadows dialog window, again, is built into SketchUp automatically. This is not part of DesignPH, but it allows us to turn on and see in real time shading information for a specific time and date. So this is great. This allows us to, in real time, move around inside of our 3D scene and get an intuitive feel for the type of shading situation that our building is experiencing. So to turn on the shadows, you're going to click that little button in the upper left corner of your shadow settings. The time zone and location should already be set by our geolocation. So because we geolocated first, all of our shading here is going to be calibrated to the specific longitude and latitude of the actual location. And then the time of day and date can be scrubbed through, can be moved through in real time there. Right, so for instance, we can take the time of day and we can go from early morning to late afternoon, and you can see the shadows moving across the day as we go from early morning to late afternoon and then maybe back to noon. So again, you can get a real good intuitive feel for the type of shading situation your building is going to experience. In the bottom there, we can adjust the date. So perhaps we want to look at summer, or maybe we want to look at winter, maybe shoulder seasons. Again, we can scrub back and forth. And then we do a little bit of visual styling there by adjusting the darkness or lightness of the shadows. If we wanted to export images, or if we just want to be able to see a little bit easier there, we can change some of the visual styling there as well. So that's all super useful, right? That's all really, really useful. It allows us to, again, get a really good feel for what's happening on the site. We can also export some images here, maybe do a nice shading assessment, looking at a couple of key times of the year, right? So that's all pretty useful. What this doesn't do for us, though, is put any numbers to anything. It's not a quantitative assessment. There's no actual calculation of shading factors or radiation incident on any of our windows. And that's where DesignPH is going to come in. So this is a really good first order analysis tool. It's going to be really helpful during the design phase. When it comes to the actual modeling, we're going to need some extra tools so that we can really start to put some numbers to these things. And so let's look at that in the next section. There we go. Sorry. So that brings us to DesignPH 2. So we'll spend the rest of this session here talking about DesignPH 2 and talking about the new shading assessment method. Again, this is kind of used alongside of that qualitative method that we look at in SketchUp. We kind of use them in parallel or sort of together with one another. They both have their place. They can both teach you a lot about the site, about the building. They both kind of teach you different things. Before we talk about any of the new DesignPH 2 methods, let's just review briefly how PHPP is interpreting or understanding shading. For each window in our project, we're going to calculate what's known as a shading factor. It's going to be calculated individually for every single window based on its shading condition. And it's going to be a number between 0 and 1. It's a factor, so 0 and 100%, which describes how much shading that window experiences. And we're going to calculate it once for the summer period. We're going to calculate it again for the winter period. So we get 2 shading factors for every single window, once for summer and once for window. Once for winter, excuse me. Now, the original PHPP 8 and 9, or the older PHPP 8 and 9, and the original DesignPH 1, DesignPH 1.5, utilized a shading algorithm which asked you to input 6 data points, really up to 9, but at least 6 data points for every single window in order to determine roughly the shading condition of that window. So we were asked to input all of the horizon obstruction, so anything like a tree or another building, which is out in the field of view of the window. We were asked to input the distance away, as well as the height of that object. We were asked to input the depth of any side reveals, as well as the dimension away from the glazing. And we were asked to input the depth of any horizontal overhangs, as well as the height above our window of those horizontal overhangs. So 6 data points. These are, we would just measure these either in CAD or in a 3D model or in Bluebeam or however you are doing your quantity takeoffs. We would just get this data. We would input it into our PHPP. Hugely laborious, very prone to error, not super accurate. So not a great method in general. Very easy to make mistakes. One of the things that people are really bad at is looking at this screen and finding the mistake. It's just not something that human beings are very good at, looking at a giant list of numbers and identifying the one that's wrong. This is not a great process, right, for all sorts of reasons. So DesignPH 1.5 significantly improved all of that. So DesignPH 1.5 allowed us to just model the actual conditions, so model the context, model the shading, model all the stuff on the site, and then it, in SketchUp, would go find all of those data points. It would sort of reach out from the window and find all of those side reveals and horizontal overhangs and horizon obstruction objects. It would collect those 6 data points and it would automatically file them away in the PHPP in just the right places. That's a huge improvement. Now we're getting the computer to do all that information. The computer is very good at looking at big lists of numbers and just remembering which one goes where. That's exactly what we want to use the computer to do. We want to just model our scene and then let it harvest all of that information. So that was a huge improvement over the old-fashioned workflow. But the downside there was that we were still using that existing algorithm, which was very fast and incredibly accurate given how fast it was, but not quite as accurate as some other calculation procedures. And so that's where DesignPH 2 really comes in. DesignPH 2 uses an entirely new process. It no longer finds those 6 data points, so that's not even part of our lexicon anymore. We don't need to do any of that. DesignPH 2 calculates the shading factors directly using a sort of reverse ray trace method, or where it starts from the window, it looks out, it finds all of the shading obstructions, plots those against the sun path, because we've geolocated our building, we know exactly what the sun path is going to look like for each window, and then calculates actual radiation on the window surface. It's going to calculate it both in its shading condition and its unshaded condition. It's going to use that to calculate shading factors directly. This is a big difference from the older DesignPH 1.5 or early PHPP methods. It's going to be a lot more accurate. It's going to be a lot easier. It's going to allow us to model much more complex shading scenes in a much more accurate way. Right? So this, in my estimation, is a big improvement. The downside to this is that it's a lot slower, especially with big complex scenes, especially with lots of polygons for neighboring buildings or topography. This shading methodology can slow down very significantly. Where the old shading methodology might run in the blink of an eye, a couple hundred milliseconds, the new shading methodology here, while it's more accurate and it's a lot easier for us to model, it could take 10 to 30 to 90 seconds to do the shading analysis, depending on the level of detail or the level of accuracy that you're asking it to do. Right? So as with everything with computers, there's a trade-off between accuracy and speed. Here, though, because the shading is so important, most of us are willing to take that 90-second hit for the most part. In any event, the way that it works is it starts from the window, it sort of looks outwards, it finds all the shading obstructions, plots them, tries to calculate what's called a shading mask. As I said, the actual calculation that it's going to perform for you is the shading factor calculation. So for every single window, it's going to calculate these shading reduction factors. It's going to look at both the winter and the summer. So again, we're looking at a sort of seasonal shading factor here. It's going to calculate the amount of shaded radiation incident on the window and the amount of unshaded radiation incident on the window. And if we just take one and divide by the other, that's going to give us what's known as our shading reduction factor, how much the solar radiation is reduced as a function of the shading around that window. When it comes to modeling, it's much simpler. We're just going to draw the actual 3D geometry of our scene. If you have balustrades or overhangs or trim or window or trees or neighbors, you're just going to draw it. And then it's going to take care of all the calculation in the background. Again, it's really much easier, much less prone to user error. But again, the trade-off there is that it is slower for sure. So the way that this works is this is the way it's always going to work with DesignPH 2. So you don't have to do anything for this to work. It's going to sort of, this is how it automatically works. If you want to sort of dive into it and sort of and get a better sense of exactly what it's doing behind the scenes, there are some good features in DesignPH 2 that allow us to see a bit of a window into the shading calculation methodology there. For instance, if we go to the shading tab in the DesignPH dialog window, so if we boot up DesignPH and we perform our analysis in DesignPH, we now have a shading tab here. If we go into the shading tab, you'll see there's a little button there that says Analyze Window. So in our 3D scene, if in SketchUp we were to select one window, just one, we can analyze that one window, and we can actually get a preview of what that window's shading experience looks like in that little shading mask diagram down below. Now we can only do this for one window at a time. So this is something of just a sort of a preview of what's happening in the background. The calculation is happening for all the windows, but we can only look at one at a time in this preview tool. So know that it is happening in the background. You just only have the ability to see one at a time. So we use this Analyze Selected Window to see what the shading experience of that selected window is. Now, there's a couple of things we need to note here in terms of the specifics. We have the ability to control or to dial in the level of detail to some extent. We can, first of all, adjust the number of rays, the number of analysis vectors which are used in order to calculate the scene. And we're able to select from very low resolution, so that might be 15 rays or 15 vectors for one window, up to very high resolution. They categorize that as 90 vectors or 90 rays used for each window. As I said before, there's a trade-off between quality and speed. If you use the very low resolution, obviously it's going to work a lot faster, but you're going to have a lower level of accuracy for the shading calculation. If you bump this up to high resolution, you're going to more accurately calculate very fine shading, leaves on trees, thinly spaced balustrades on a railing, screens or louvers. You're going to be able to more accurately calculate those, but it is going to take a lot more time, just a lot more computation for the computer to do in the background. So the usual recommendation here is during most of your calculation or most of your time working to keep it set on the low resolution. So get everything set up, get everything working with everything at low resolution. And then when it comes time to really export out to PHPP to do the assessment, in that case, then you would bump it up to the higher resolution. So as with everything else, we kind of work with it in a slightly crude fashion, and then we bump it up to higher levels of detail when we're sort of ready to export, ready to go. So that's one level of controllability that we have. You can see the effect of it in the preview here. So if we were to, in our 3D scene, select that window in the left, the one with the blue highlight there, so we're selecting that window using the typical selection tool in SketchUp. We then go into our DesignPH and we choose Analyze Selected Window from the Shading tab. If we set it at very, very low resolution, so only 15 rays per window, or whatever the specific subset there is, what you'll find is that the preview, the shading mask preview, looks something like this, relatively crude. It'll still do the calculation, it'll work, it'll get pretty close, but obviously it's a little hard to see what's happening there. We're not really able to see a tremendous level of detail. It's just a function of the coarse nature of the analysis. But if we were to bump that up to very high resolution, maybe 90 rays per segment of the window, notice the resolution or the image there starts to come into focus. It's sort of like you had a picture, right? That you look through a camera and it's out of focus, and then it sort of clicks into focus. All of a sudden, we can see the staircase there on the right-hand side coming down. We can see the horizontal overhang. It's all kind of odd. It's a fisheye view, right? You're not. Everything, it doesn't look straight because it's a fisheye sort of view from the window looking out, but you're able to sort of pick out the pieces of the geometry and the elements that are doing the shading around it. So going from low resolution up to high resolution is a really useful tool to get a window into what's happening for this window. The other thing to see, or the other thing to note on these shading mask diagrams here, is the sun path. So notice those little red and yellow those little red and yellow dots, those are describing that's describing the path of the sun. So the arc that's down at the lower portion is going to be the wintertime sun, and the arc of dots up at the upper part is the summertime sun. If you've ever looked at a solar pathfinder or you've used stereographic projections before, you'd be familiar with these sun path diagrams. So what this is showing us is that this window, due to its horizontal overhang, is quite exposed to wintertime sun. The stare there cuts off a little bit of the late afternoon sun, but in the summertime, this window is quite shaded from the sun, right? So we can start to analyze or review the shading diagrams here to get some information about what's happening with our windows. Again, we can only do this for one window at a time. So we can only look at one element at a time, but it does give us a window into what's really happening inside of the background here. Now, the other level of detail that we can control using DesignPH 2 is how many analysis points we want the simulation to execute. So by default, it's going to do one set of analysis points from the very center of the window. Of course, we can bump that up. We can say, actually, I want you to subdivide the window into 16 segments. And for each of those segments, I want you to calculate a shading factor. And then I want you to do an area-weighted shading factor average for the whole window. That's fine. That's going to give us a much more accurate level of detail. So if we bump up to high resolution and we bump up to 16 points per window, we're going to get a really, really good answer. We're going to get a good final result, but obviously it's going to take a lot of time. Right? So just like with everything else, we're going to significantly increase computation time as we subdivide these elements. Everyone nowadays is familiar with exponential growth. So as we go from 1 point to 4 to 16 points, the computation time does not scale linearly. So we can significantly increase the amount of hours that our computer is going to chug away if we go up to 16 points and very, very high resolution. Now that may be warranted and it may be necessary for your project. You may want to do it. But again, typically when we're going to work using the lower resolution, get everything rigged up, get it all working properly. And then once we're certain that everything's working, that's when we would shift to the really high resolution, go get lunch, come back after that, and then see what we got as some output. What this simulation is actually doing in the background is simulating radiation incident on the window. So the way it calculates those shading factors, remember, is by first figuring out how much radiation would be incident on the window with no shading. So it eliminates all the shading from the scene, calculates radiation. Then it brings radiation back in the scene and it calculates the radiation as a result with that shading in the scene. And then the difference, or the one divided by the other, is going to be your shading factor. Radiation, though, solar radiation, is made up of several different components. There is, of course, the direct beam radiation, which is what SketchUp's built-in tool is sort of showing us, right? When we're looking at the live preview of shading in SketchUp, what it's sort of showing us is shaded or unshaded, right? There's a pretty crisp line there. SketchUp is not taking into account things like diffuse radiation reflected off the sky dome, the horizon brightening radiation that happens down at the horizon, or ground reflected radiation for that matter. DesignPH 2 is going to take all of these components of radiation into effect when doing its calculation. We also, in DesignPH 2, have a window into the specifics here. So in our shading tab, well, down a little further below the shading mask preview there, we actually have some detailed area graphs that show us the radiation incident on that window, both in its unshaded condition, that's the one at the top, and then its shaded condition, that's the one at the bottom. This is looking at the whole year, and it's looking at one average day for each month of the year. So that's what you're seeing here is January on the left, February, March, April, May, going all the way to December on the far right. And so you can see the different levels of shading throughout the course of the year. Now, this is a little hard to see what's happening in this graph here. So if we change the level of presentation and we go from looking at the whole year to looking at just a single month, it becomes a little bit more obvious. So this is an average day for the month of June in this location for this building on this window. And what you see here is the radiation broken down into those constituent parts. So we have our beam solar and our circumsolar diffuse. We also have the diffuse off the sky dome. We have the horizon brightening radiation, and of course the ground reflected as well. And you can see it in this area graph here, all of those constituent pieces. On the upper graph is the unshaded radiation that would fall on this window. And on the bottom is the shaded radiation that actually does fall on this window. And notice the difference between these two for this particular window. You know, that horizontal overhang does a pretty good job of knocking out all that direct beam solar. Obviously, a horizontal overhang is not going to do anything to knock out any ground reflected radiation, though, is it? And so you can see that in this data right here. So clearly the direct beam gets reduced significantly, but things like the diffuse isotropic or the ground reflected are going to be maintained. Something like a horizontal overhang is not going to affect those in any way. So this gives us a really nice window into what's happening in our buildings. Gives us quite a bit of detail. This would be useful during the design phase, try and figure out where and when and how I should be composing my shading to most effectively shade and reduce the risk of overheating in my passive house buildings. Just a couple of examples of what that sort of looks like, or just to show a couple other examples, to show a couple other different situations. Just a really simple little example building here. If I was to do an east-facing window, for instance, and do the radiation analysis here, notice what we see in the radiation graph there, just as we would expect. That direct beam solar peaks about 8 a.m., just what we would expect. Early in the morning, the sun is low in the sky, that radiation's coming in at a very low angle, and it's virtually perpendicular to the glazing surface. So we're gonna have a lot of early morning solar radiation on an east-facing window. Notice by the time it gets to noon or into the afternoon, we have a lot of self-shading by the building. So we're no longer getting any direct beam, but of course we're still left with quite a bit of reflected radiation off the hemisphere and the horizon, as well as the soil. Contrast this maybe with a south-facing window. We see a much more symmetrical distribution of our radiation throughout the day, as to be expected. We have almost no early morning radiation. The south-facing window is going to have a lot of self-shading from the east-facing wall. We are exposed to a bunch of radiation in the middle of the day, and then the radiation dies off again towards the end of the day as we get, again, a lot of self-shading from the other surfaces of the building. So for a south-facing window, we might have a very different distribution, a very different solar experience than an east or west-facing window. Again, this is most useful when trying to ask the question of how do I compose my shading? How and where do I deploy shading in my building to most effectively knock out that harmful beam solar radiation? Right, the direct beam is what we're going to be most concerned with when it comes to physical discomfort, overheating experience of our occupants. And so you can use this to help guide you along the way. Useful tool for sure. And then lastly, let's just talk about our trees. Always comes up when it comes to discussions of shading. How do we deal with trees? In particular, how do we deal with deciduous trees? Well, the way that we do it in our DesignPH 2 universe is significantly improved over how we used to do it with our DesignPH 1.5 or earlier versions. Essentially, we just draw a tree. Luckily for us, we would not actually draw this tree. As I said before, one of the things about Sketchup, which is quite nice, is that there's a really robust third-party developer ecosystem that make plugins for it. There's also a very, very lively modeler community that create these 3D models and then deploy them to an online repository where you can sort of find them and download them into your scene directly. So built into SketchUp are some navigation tools that allow you to look around for these types of models. I did not draw this tree. Some poor intern drew this tree. We just downloaded it and we deployed it in our building. And it works really well. The leaves are on one layer, so we can turn them on and turn them off. We would obviously turn them off for wintertime shading analysis and turn them on for summertime shading analysis. So having a good tree that's set up nicely, that has the leaves able to be turned on and off, is going to be critically important when it comes to deciduous trees. Obviously would not be important for evergreen trees. You could use a different model for that. But there are lots of trees. There are literally thousands of 3D models of trees available in the 3D warehouse through SketchUp. You can just download them for free and deploy them into your building. Now, the one qualifier or the one warning I would give you is to make sure and clear it or make sure and come to an agreement with your building certifier. So if you're doing a PHI certified building, talk to your certifier about what types of trees they think are appropriate to use and which ones would be appropriate for your scene. It'll be a negotiation. There's no hard and fast rule about this is okay and that's not okay. But you know, talk to them about it. Try and find a tree that matches the height, the canopy shape of the trees that are actually in your scene. You want to try and be as accurate as possible to the real condition that your building is going to experience. That your building is going to experience. The way we would deploy it is quite straightforward. We just put it into our scene, right? We just model the shading as it actually exists. Much simpler than some of the older methods where we had to do some complicated workarounds. Here, just model what actually exists. So maybe we have a tree out behind or in the eastern part of this, on the eastern face of this building here. If we were to do our analyze selected window, like we looked at before, and look at the shading mask, you can see in the very center of the shading mask there, the kind of wispy trunk and branches of the tree showing up. If we perform the analysis in its unshaded state, obviously we're going to have a lot more solar radiation, which is going to come through the tree. It's going to block out a lot less radiation, but still some, right? There's still going to be some, 15, 20%, which is occluded by the tree. However, if we move to its fully leafed out state, notice what happens in that shading diagram in the lower right is we have a much more, much less transparent, much more opaque shading element, shading mass in the center of the scene there. It's going to block out a lot more of the solar radiation. As a result, we're going to have much lower shading factors for a window in a leafed out state. So we can go back and forth. We can do that analysis for wintertime or summertime by turning those leaves on or off. It gives us an easy way to do very, very accurate shading. Now, the other sort of qualifier or the other warning that I would give you is the same warning I've given you before. With a lot of polygons, the more polygons you have in your scene, the slower the shading calculation is going to go. So if you have a lot of very, very complex shading elements like trees in your scene, your calculation is going to take a long time. So try and be judicious, try and deploy them only where you need them. Try and use the lowest poly version of a tree that you could. For instance, here, it would be really nice if we could sort of flatten out the trunk and the branch. We certainly don't need those to be actual rounded elements. Maybe there's ways that we could sort of simplify this tree and abstract it so that we still get good shading quantification, but we don't have the really high computation times. So just a warning there, it will definitely get slow if you have really high polygon models deployed in your model there. But in general, works very well, gives us really accurate results. We've tested it in all sorts of different configurations. Seems to be working very, very well for all the situations that we've run into. So with that, we'll come to a close here. So it looks like we do have some questions here. Would love to go over these questions, and then we'll finish up here with just the last couple. So if you guys have other questions, feel free to add those to the chat here. I'd be happy to answer any questions. We could do a little live demo if we have a few minutes left at the end here. So some of the other questions I missed, IP version. So Caleb asked about IP version. Yeah, I don't know when the IP version is coming out. It's a good question. The DesignPH 2 allows for IP export, so you can export all the data to your IP version of the PHPP, but you can't natively model. You can't enter, really where it comes up is with assemblies, assembly thicknesses and lambda values. You can't enter those in IP, which is frustrating for sure. I've heard they're working on it, but I don't have a time frame on that, I'm afraid. Tom says there a toggle ability to go between geolocation and design axes? Do you have to reset the design axes each time? You have to reset it each time. So unfortunately, there's no sort of, you can't save, to my knowledge anyway, you can't save a construction plane, sort of toggle back and forth, sadly. What we'll often do is, we draw in some temporary geometry that shows, just like a cross or something that shows our rotated geometry. And then we can use that to snap to, so we can easily get back and forth between it. But you do have to physically reset it each time when you change your design axes, unfortunately. Dan asked, can you import Google Earth 3D data covering the section from the context model? Not that I know of, but I mean, there are some plugins that allow you to do that. They're a little bit weird. The Google Earth 3D data is a little hard to extract. They intentionally make it a little bit hard to extract from those scenes. There are some methods to do it, but they're a little bit complicated, unfortunately. So it doesn't come in by default. Now, The tool that we've been using to get around that, or the easier tool that we use to get building heights, is actual GIS data, and you can get that automatically through something like OpenStreetMap. So if you use openstreetmap.org, you can navigate to your location and you can download an OSM file. That OSM file is going to have all the GIS, the municipal GIS data that's publicly available. And that's often going to include, or it's almost always going to include, building heights. And if not building heights, then building levels, number of levels. You can just do a 10-foot per level sort of assessment. So you can get both building footprints, polyline building footprints, as well as metadata for each property using that OSM file extract. And that's all freely available through OpenStreetMap. So we do that for a lot of our, for most of our projects. It's a very accurate way to do that, for sure. Okay, so some other questions there about certificates and recording. So it looks like that's all straightforward. Andrew Marsh has an amazing SunPath diagram program for free. So there's great SunPath diagram tools out there. If you're not already working with SunPath diagrams, there's a learning curve. They look weird at first. But they are a critical tool to become familiar with and to begin to fold into your design process. They're the best tool that we have for assessing shading and getting a good feel for what's happening with your building there. So Steve asked, how important is very accurate representation of exterior shading elements, trees, geography, etc., compared to a well-designed building with appropriate overhangs? That's an interesting question. I'd be really curious to know a little bit more about what you mean by that. My instinct is that the way we design well-designed buildings with appropriate overhangs is by doing the math, is by doing the assessment. That you're right. That's what we're after. Is a well-designed building with appropriate overhangs. That's what we're trying to create. And the way that we do that is by doing the math and by looking at these shading assessments in lots of different ways. We do the SketchUp, sort of interactive shading. We do DesignPH, and then we have some other tools that we might yet deploy. There's some other things that we might even use. But you're right. I mean, that's the goal: is to make a well-designed building with appropriate shading, avoid overheating risk, keep our occupants comfortable at all times. Exactly. Michaela asks, but if you have more, if I misunderstood your question, Steve, please, I'd be super curious to know what you meant by that distinction. That's an interesting question. So Michaela asked, how do you export winter summer when you're turning on off the leaves? Do you have two? Yeah, do you have two PHPPs? Yes. So currently, the way that it works is you turn on the leaves, you export. You turn off the leaves, you export. And then you just have to do a little copy paste to weave those two together to take the wintertime shading factors from one and the summertime shading factors from the other and combine them together into one PHPP. So unfortunately, they don't do that automatically yet, but I'm told that they're working on that for the next version. So right now we just have to export two and then weave them together. Then Ryan asks, where are you getting site geometry and how accurate does it need to be? Does it calculate reflected radiation? Good question. So where we get the site, well, there's two things. Site topography, so hills and such, we're bringing that in from the geolocation. So as I indicated earlier, when you geolocate through SketchUp, you do the import tool, that's going to automatically bring in the topography data. That's great. Then when it comes to building footprints and building floor levels and the like, we're going to get that from OpenStreetMap. So OpenStreetMap, publicly accessible GIS database, allows us to get both building heights in most cases, in most municipalities, but if not building heights, then at least number of building levels. But for sure, we're able to get building footprints if you're working in an urban location, I should say. Well, most places are going to have it through OpenStreetMap at this point. So you're going to be able to get building footprints that way, and then you're going to be able to extrude those up. If you need to build out much more detailed, the neighbors right next door, if you need to build that in a more detailed fashion, you just do just the old-fashioned go on site, take photos, and try and build that as accurately as possible. But that would only be for if it's really critical and it's right next to the building. In general, we can get almost all that we need from those OpenStreetMap GIS data sets. Does it calculate reflected radiation? So the current DesignPH 2 does calculate reflected radiation from the ground. There is no ability to change the albedo level though. So we can't actually say, oh, I'm right by the ocean, so I'm going to have a really high level of reflectance off the soil. We can't say, oh, in the wintertime, I have a, snow cover, and so I have a much higher level of reflectance. It's a hard-coded data point right now. So unfortunately, we don't have the ability to change the albedo of the soil, but it is being taken into account. We just it's a set value. And I don't know what it is off the top of my head, to be honest. 0.6, something like that. Lindsay asked, if you use ArchiCAD and export as a SketchUp model, should you remove the ArchiCAD trees? Probably. I'm not sure what the ArchiCAD trees look like, but most likely. Yeah, if you're exporting from some other package, you're probably going to want to clean it up and reduce it down to just the sort of the bare minimum set of geometry that you would need. You could try it, but probably what's going to happen is you're going to end up waiting 20 minutes for it to calculate. You're probably going to have a really long calculation time. Dan said, I know it's not a common issue, but how do you incorporate elevated train tracks into the SketchUp model? That's a good question. We would try and model them in. It's not uncommon. We work mostly in New York, Brooklyn, Jersey City, Hoboken. We have all sorts of weird shading contexts. You can get a lot off the internet, but at a certain point, you're just going to have to actually model it. So you're going to have to go, take some site measurements and take some photos, get on the site and actually build those out. If you can't, you can get a lot off the internet these days, but at a certain point, you're going to have to really model that out. And certainly we have done that. I mean, there's lots of weird shading conditions that we find ourselves in, and often we do have to, build out quite intricate models for sure. Oh, and then Steve had added something too. Steve, it's very context dependent. For some situations, non-urban, the effect of the externals may be fairly insignificant. Just using sun path analysis and building characteristics may be enough. Of course, the more accuracy, the better. Yeah, no, it's a good question. I think you can get pretty far by using best practices and patterns that you have deployed successfully on past projects. You're probably never going to convince me that doing the math is a waste of time. There are people who try. I have a lot of good colleagues who are getting fed up with doing the math. I still find it to be valuable and useful. I think it's a useful tool, and especially as the tools get easier to deploy. We're not really doing any math. We're just building the scene. We're just drawing the scene. It's the same kind of stuff that you would be drawing for your architectural model. Luckily, most of the analysis is done in the background now. So they've started to make it, I mean, it's not simple by any stretch, but it's easier than it used to be in my estimation. So it's a lot easier to deploy it and get some useful results. Should always be taken with a grain of salt. You should always, as you're indicating, use your experience. The math doesn't override your lived experience. If you know that this works, the math isn't going to override that. But we have certainly found it to be useful, and it still teaches us a lot. We use it in combination though. As I said, we use those qualitative assessment in SketchUp, where we sort of look at things in real time and we scrub it around, we calculate some numbers, we do some on-site shading assessment. It's a combination of tools that we use to ensure thermal comfort in these buildings. And of course, we're always learning a lot from each building that we do and trying to fold that into our process moving forward. Yeah, definitely easier than it used to be. Yeah, for sure. Yeah, definitely. Okay, so it's actually a little bit after 1, so we do need to finish up. We'll respect everybody's time here. So thank you so much for attending. Really appreciate it. I hope this was useful. Hope it gave you some tools that you can deploy on your projects moving forward. As I said, keep an eye out for all of those upcoming NYPH sessions. And just the last piece here, in case you're not familiar, I'm sure everybody here already is, but in case you're not, there is an upcoming North American Passive House Network conference going to be every Wednesday afternoon in June. So please make sure you register for that. There's going to be some really interesting sessions there. And if you have any questions at all about anything here or related to SketchUp or tools or anything else, feel free to shoot me an email, get in touch with me or any of the folks at New York Passive House. Be happy to hear from you, be happy to answer any questions you guys might have. So with that, I'll say we'll close out here. Thank you guys.